Space Industries is developing the Lunar Resource Extraction Vehicle, which is our flagship mission to produce water on the Moon and Mars. In doing that, we're developing a number of technologies, which includes a large 3D printer, which is designed to print polyether ether coatine, or PEEK. That's a replacement for nylon and Teflon. So oil and gas industry, as well as defence, can utilise that 3D printing capability to improve composite materials, as well as better thermal insulation. Some of the other technologies we're developing for the main flagship mission is the fuel transfer port, which has capabilities for subsea operations, for transferring power, as well as transfer of power and fluids on the move, so in air or while vehicles are moving. And that also has applications for satellites, as well as transfer of resources like water or gas and power on the Moon and Mars. Some of the other products we're developing for Earth-based applications coming from our resource extraction vehicle is the mining processing method. So we've been able to put that together in a way that allows us to process and capture ores on Earth, and we can capture all of the emissions from those ores, as well as separate various minerals from the ore in a new method. So one of the reasons why we came up with mining helium-3 on the Moon is that helium-3 is very scarce. The only way that we produce that on Earth is by making nuclear weapons. There's a couple other methods like using nuclear power plants, but it's not economical. Helium-3 is very important. It's used in MRI scanners to keep the magnets cool. It's used for MRI imaging, so you inhale the helium-3 and it can give super high resolution images of your lungs to detect different diseases. And it's also used for neutron detectors, so the oil and gas industry, they'll wear a little device on them called a neutron detector, which helium-3 is stable and non-radioactive, so it's the only isotope that can be used for that. That can also be used for national security. So the USA depleted their helium-3 reserves after 9/11. They put neutron detectors around all the borders, so seaports, airports, and also in cities. So they're two of the biggest applications. The biggest future application is nuclear fusion energy. So over the last couple of years, that's had some pretty big advancements, and we're looking to see that commercialised hopefully over the next few years. And with very limited supply on Earth, the supply for helium-3, which is the fuel for nuclear fusion, needs to come from the Moon. For the last couple of years, so even before incorporating, we've been working on a new mining method to produce the helium-3. So the helium-3, we first looked at how does it get to the Moon. It's deposited from the sun's radiation. So the sun deposits its radiation into the lunar surface. The helium-3 gets captured inside the small pockets inside the ilmenites. Those ilmenites are also associated to titanium. So for future production of structures on the Moon, it's also a good location focused on the titanium and the helium-3. So we can do multiple things at once. With that as well, when the sun deposits its radiation, it's depositing protons into the surface. Those protons combine with electrons and form hydrogen. Already in the lunar regolith is about 43% oxygen. So the oxygen and the hydrogen come together and it forms water inside the lunar regolith, which is the soil on the Moon. That's bonded with silica. So the natural environment heats to around 140 odd degrees, which is not enough for that water to break the bond from the silica and release. So we focused our mining method on producing water that's hydroxyl inside the regolith, which means also we can produce water anywhere on the lunar surface, which has had the sun exposure. So what we do is our vehicle heats up the regolith in a continuous mining method. So we don't use a traditional mining method where it's stop and start, or you have to drive from one location where you process to the mine site, extract it, transfer it all the way back. That's very inefficient. So what we do is we have an onboard storage. We heat the regolith to a certain temperature. That then outgasses all of the isotopes. So the bond is broken, the water releases as steam. We then capture the steam, use temperature and pressure to convert it back into water, and there you go, we've got water. So that's the process of how our vehicle works. Our company has achieved good traction in the industry. We were selected as a final top 10 company by NASA iTech and presented to subject matter experts in Las Cruces in America, and that got us some pretty good traction. We've also been selected as a finalist for 2 of the Australian Space Awards, which was finalist for Innovator and also Startup of the Year as well.